Hi, thanks for joining WellSite Data for another video. Today we're going to be discussing our chromatograph functions. Not the separation of the gases, but our software for integrating and interpolating the curves. Note that we have 7 curves here. This is our simulator. We are fully capable of eluting 7 different types of gases, C1 through C6, including the isos and neos of both C4 and C5. This was done so we can practice integrating and interpolating curves without burning a lot of test gas. Near the center of the screen in the upper part is a small gray window with a number in it. That is the depth, the lag depth, there we are, the lag depth from which this sample was taken. What we're going to do first is we're going to back up to the very first chromat in this sequence. You see these arrowed buttons on either side will allow us to go forward or backward, one at a time, or to the first or to the last. That was telling us we're at chromat foot number 201, not the record number, but the actual depth it was taken. We can thumb through these and see the differences in how the gas profiles changed with increasing depth. We'll thumb through a few of these. We'll go back to the beginning, and you see that we have these, how many? 1, 2, 3, 4, 5, 6 peaks. I'm going to thumb through a few and to see what we can look at here and see the changing profiles. Now we're going to just tell this one we don't want to use that one. We want to take that one out of the database because we feel there was something wrong with it, or perhaps it was taken when there was no gas present whatsoever and we got a blank curve. Well, we can skip it in the database by simply hitting integrate. Now if we decide at some point that that is a valid chromatogram, we can go back in the future starting with C1, go to the edge, the beginning, click on the mouse, and it snaps to the curve line and colors C1 in blue. If we lift and click back down, it's going to ask us C2 is next. We go ahead and click down saying yes, mouse over that, and we'll integrate C2. The same procedure for C3, IC4, NC4, etc. And then we hit interpolate, and that will give us the percentages. First it threw parts per million is the first data you see right after the colored component number. When we hit interpolate, this calculates the percentages of each gas relative to the whole and puts the numbers in the database. Only colored interpolated records are added to the database. If they're left in this state, the software overlooks them. For instance, if there's 30 in a row that look the same, there's no need to interpolate all of them. Only interpolate the changes. There's less data to be processed, and it's not a meaningful change anyway. So the user can simply click through, skipping over. Here we made a mistake. We say that this is all methane. All the curves are methane. The user has complete control over this, but we know better. So once we've reviewed the others, we can go back and say there's something wrong with this one. Let's either reintegrate it and leave it out, or we're going to reintegrate it, finish the job here, click interpolate, and put those percentages in the database. Had we left a plain gray curve, this would be overlooked by the software that creates the LAS function. We feel the user needs to have this kind of flexibility so that automated systems often throw errors. We've seen some very strange things on logs done by semi-automated systems that were confused. Also, the user visually integrating these and interpolating these has in his mind now a color profile of how the gases looked at each depth. He will remember where the preponderance of gas is. Is it over on the methane end, or is it down on the pentane or hexane end? Giving him an idea of the balance. As he looks at rocks, gives him an idea of the profiles. Here we're changing our elution time. In an earlier part of the well, you may only be concerned with methane and ethane and wondering, is propane even available? In the 30-second, our first click, a 30-second elution will give us methane, ethane, and propane in about 30 seconds. About half of the propane peak will be exposed in 30 seconds. If there's no propane, you can continue running 30-second intervals, just to give a quick check shot and be ready for the next one. If you see propane, then you can lengthen the time of elution to encompass that curve as well, and any others that follow. Also, the system will selectively elongate the elution times if high gases are present, because if there's high gases, we're going to assume that they have heavier components. We're going to open up the elution scale and see all of the components available. We can also change the amount of time that our sample valve is open, so that smaller amounts of gas we can open up and get larger amounts of it. Larger amounts we can close it down and get smaller amounts to stay in the chromatograph's most linear range. We haven't really gotten into the auto scaling function, but we can. Thank you for watching.